Thank you very much, Danielle. For this closing session, I will give the floor to Takahiro Wada. And this is an opportunity for me to say that we have wonderful testimonies, videos from the YouTube channel from the Japanese photovoltaic community that is extraordinary. And I will leave the floor to Mr. Wada now for this closing session. Thank you very much.
I would like to move a closing section. Do you hear me?
Perfect. Yes, perfect.
Okay. I am Takahiro Wada of Ryukoku University, Japan. I entered the field of photovoltaic science with development CIS solar cell in 1991. I serve as project leader of high-efficiency CIS solar cell research in Matsushita Electric, now Panasonic Corporation. I moved to Ryukoku University in 1994. I continued to study CIS solar cell from material science point of view. A first speaker is Catherine Langlais. She is president of French Society of Physics. She has worked for Saint-Gobain as director of Saint-Gobain Research Paris and then as deputy director of R&D Saint-Gobain. And she received a Legion of Honor in 2012. Please, Catherine Langlais, please. Dr. Catherine Langlais.
Merci, j'espère que vous m'entendez. Je vais partager mon écran.
I'm going to share the screen. My screen.
Est-ce que vous voyez mon écran maintenant?
When the organizers of this seminar, and Danielle Lanco asked me to say a few words for the closing ceremony, I wondered about the form that this presentation could take. And after having a thought of the work and the life of Edmond Becquerel, I felt that it would be interesting to share with you a number of thoughts that I believe Edmond Becquerel may have inspired amongst, or could inspire amongst researchers in physics today. If you allow me, I'll start with personal testimony. He was a source of inspiration for me because I belong to the generation of those who at the end of the 70s, after the first oil crisis, the first energy crisis, took interest in solar energy. And I was fortunate to do an internship at CNRS laboratory and worked on the solar installations that you see and solar houses. And then I went to California, but unfortunately when I came back from California, where lots of things were going on in the solar sector, there weren't any companies that could provide me with a job. And I went to Saint-Gobain because I recalled that the mirrors of the solar furnace were produced by Saint-Gobain. And I joined them. And in the years 2000, when I was head of research, I had the opportunity to coordinate for Saint-Gobain research on solar energy, because Saint-Gobain is very skilled at layers on glass. They were able to produce CGS solar devices. And in the years 2000, when Saint-Gobain wanted to launch its new products, the Chinese cells were at a very low cost, and Saint-Gobain gave up on this project. Now we can see that the photovoltaic story can be an example of to and fro between basic research and applied research, fundamental research and applied research. And here you have on screen a slide from a lesson that Didier Roux gave, and Didier, who likes to explain between the moment of discovery, and we're talking about the discovery made by Becquerel in 1839, between the time of that discovery and the real innovation, and that is the use of this discovery, application of this discovery in a given market, there's a lot of time that goes past. And very often people rediscover the discovery. And Didier Roux mentioned in 1954, Bell Labs produced the first silicon solar cell for satellite application. We had to wait for a certain amount of time for photovoltaic to be applied in the generation of energy. Becquerel, who wasn't seeking to generate electricity, and now where we are today, there has been a certain amount of time that had to go by. There was much to and froing, and this will continue to be the case between fundamental research and applied research. Here you see the best yields of solar cells and solar modules for different generations, but since perovskite, back to the first ones, the silicon cells, you see there's always a difference between the best modules and what can be done in laboratory, but gradually this fertile exchange between academics and engineers in industry has meant that the yield of these modules has continued to grow. That is a fine example of what research and industry can do together. Now, when we come back to Edmond Becquerel and his relations with the French Society, Physics Society, it was the end of the 19th century when we began to create the first 7 societies, academic societies. At the time, it had been noted that certain institutions like the Science Academy were too elitist. And there was a movement to set up much more open organizations, open to people who wanted to discuss disciplines. There was the Société Chimique de France and the Société Mathématique de France was created. And 1873, a group of physicists who liked to get together to talk about physics at the École Normale Supérieure, decided to set up a society for the promotion of physics and to share knowledge with the public. And if you go to the site of SFP, you'll see archives. And at the first meeting of the Société Française de Physique, it would seem that Antoine Becquerel was present, Edmond's father, and that Edmond Becquerel was appointed with much acclaim, because that's the way it was done at the time, as an honorary member. And since this society wanted to be open, so it was customary to present research findings, and Edmond Becquerel presented research findings, and later his son became himself the president of the French Physics Society. So I believe, although I'm not a specialist of Edmond Becquerel's life, but I would say he has all the necessary qualities to be a physicist. He was an excellent experimenter who had a taste for applied physics. He was president of the Society for the Promotion of National Industry, but he was an experimenter at the same time who published. He published many articles, many papers, and he was above all an experimenter. Compared with other scientists of his time, he wasn't he wasn't obsessed by formal mathematics. He was very much liked as a teacher because he was very accessible for his students. And at a time when chemistry and physics were not disciplines that were so much apart as they are today, we could say he was a physicist and a chemist. And physicists and chemists today are more and more required to work together to be able to address the challenges of the future. Very recently, in April 2018, the French Society of Physics and the French Society of Chemistry published both in consultation, what we call Careducta, that you can find on the web to make recommendations as to what should be done in research to be able to ensure the energy transition. I'm not going to detail these documents, but I would like to quote two things. The first quote you have up on the screen is calls appeals for generating electricity with new renewable sources, with which are calls for finding solutions using electrochemical and chemical processes, and to include the cost of the transport and distribution of the energy. Now, this publication also talks about the importance of research in the energy transition by reminding us, and I find that this is really important, and we should think about this quote, because they say that the energy system humanity was built mostly in the last 2 centuries based on discoveries, just what we have been talking about, often unexpected or discoveries, and thanks to researchers in all the disciplines. And that because of this research was taken up by manufacturers and industry, and that's enabled to apply these discoveries to the energy transition that we are engaged in today. Now, this research, I would like to talk about a number of aspects that are close to my heart. I mustn't forget, because in France it is a topic which requires work, the importance of training thanks to doctorates. So research through research, and I've noted how often physicists who had obtained a doctorate were able to address very complex problems. And what I've noted for all innovations, diversity is key, whether it be gender diversity, whether it be in terms of disciplines, generations, and of course, cultural diversity. You cannot have innovation without this far-reaching or wide-ranging diversity. I would say go to our site on the SOP, you will see our chart for parity and diversity that we would like to see shared with other research societies. I would like to highlight the importance of mutual or cross-fertilization between fundamental and applied research on an equal footing. We saw that Becquerel discovered photovoltaic effect by chance. So fundamental research without any precise objective is essential to be able to develop applications in industry for the future. And I would say during this period of COVID, we all understand how the contribution of scientists, whether they publish articles and make presentations, it's very important of importance of being able to challenge people's findings, but also to be able to answer these challenges. If you go to the Jardin des Plantes, you will see an alley which is dedicated to the Becquerel family. It is the Becquerel Alley. And it seems to me that this alley becomes an avenue or boulevard for researchers of the 21st century so that they can take up all the challenges of the future. We talked about the generation of energy. We could talk about energy efficient, sustainable mobility, health, quantic systems, and also new materials. And the physicists of today should take up this boulevard, this alley, and contribute to taking up the challenges of the future. To conclude the seminar, the interpreter apologizes, there's some weird sounds, I can't hear the speaker. Now, It is interesting to note that the latest Nobel Prize winners in France, somebody is making noise. I cannot interpret. Please stop the noise. Now with Jérôme Moreau has done work on lasers, for instance. And as you know, La Roche has just brought out a book called The Light Revealed. The heritage of Edmond Becquerel is very much present today, and we should continue to take inspiration from it to develop it further. And this is what I wanted to share with you on the occasion of this closing ceremony. And thank you for your attention.
Thank you, Dr. Langlais. Thank you very much.